Ever wonder how we can blast a massive hunk of metal and fuel into space at incredible speeds, defying gravity and reaching for the stars? Join us on a thrilling journey into the science of rocket propulsion and space travel to unravel the mysteries of the universe and explore cutting-edge technology. What is rocket propulsion? Rocket propulsion is the system that powers a rocket. Modern rockets work by igniting a propellant. As the propellant is combusted, it is converted from a solid or liquid form into a gas. The gases are pushed downward, through the nozzle, and out of the open end of the rocket at high velocities. As the exhaust gas is pushed downward out of the bottom of the rockets, the gases also push the rocket upward with an equal and opposite force. Types of propellants. Modern rockets generally use one of two types of propellant, liquid or solid. Liquid fuel rockets carry fuel and an oxidizer in separate tanks. Solid fuel rockets have their fuel and oxidizer pre-mixed in the appropriate ratios. In both cases, the fuel and oxidizer are combusted at high temperatures and exhaust gases are violently pushed out the bottom of the nozzle. The study of modern rocketry relies on the understanding of four basic principles. The first is combustion, the process of burning fuel. The second is thrust, the push of the exhaust gases. The third is a mass ratio, the ratio between a fully fueled rocket and the rocket when empty. And the fourth is specific impulse, a measure of the engine's efficiency. To maximize the effectiveness of a rocket, scientists must somehow harness combustion, increase thrust, minimize the mass ratio, and maximize specific impulses, all while traveling miles above the ground. How do rocket engines work? Modern rockets work by igniting a propellant. As the propellant is combusted, it is converted from a solid or liquid form into a gas. The gases produced have such a high volume and are under such intense pressure from the heat of combustion that they are pushed downward through the nozzle and out of the open end of the rocket at high velocities. From there, Sir Isaac Newton takes over. Newton's third law of motion explains that for every action, there is an equal and opposite reaction. This means that, simply stated, forces come in pairs. As the exhaust gas is pushed downward out of the bottom of the rockets, the gases also push the rocket upward with an equal and opposite force. The amount of force depends upon both the mass of the gases and the acceleration of the gases. And because the rocket itself is so much heavier than the exhaust, large rockets will usually move slowly at first. But as the combustion process continues and more gas is ejected, the rocket receives a constant push. Their acceleration can take it to truly astronomical heights. The science behind it. Rockets range in size from fireworks so small that ordinary people use them to immense Saturns that once propelled massive payloads toward the moon. The propulsion of all rockets, jet engines, deflating balloons, and even squids and octopuses are explained by the same physical principle, Newton's third law of motion. The matter is forcefully ejected from a system, producing an equal and opposite reaction to what remains. Another common example is the recoil of a gun. The gun exerts a force on a bullet to accelerate it and consequently experiences an equal and opposite force, causing the gun's recoil or kick. Thrust is the force which moves any aircraft through the air. Thrust is generated by the propulsion system of the aircraft. Different propulsion systems develop thrust in different ways, but all thrust is generated through some application of Newton's third law of motion. For every action, there is an equal and opposite reaction. In any propulsion system, a working fluid is accelerated by the system, and the reaction to this acceleration produces a force on the system. A general derivation of the thrust equation shows that the amount of thrust generated depends on the mass flow through the engine and the exit velocity of the gas. The science behind rocket space travel. A rocket moves in space, because the gases are given momentum as they are expelled by the rocket engine. Consider the rocket resting in space. There is no momentum in the system. Next, the engine ignites. As the exhaust gases go in one direction, the rocket goes in the other to keep the total momentum of the system constant. This momentum change of the gases gives the rocket the push to go forward. We call this push the thrust of the rocket, the force exerted on the rocket. This thrust depends upon the speed of the exhaust gases and the mass of gas being expelled each second, sometimes called the burn rate in pounds of fuel per second. On Earth, air tends to inhibit the exhaust gases from getting out of the engine. This reduces the thrust. However, in space, since there is no atmosphere, the exhaust gases can exit much easier and faster, thus increasing the thrust. Therefore, the rocket engine works better in space than here on Earth. In space, rockets zoom around with no air to push against. What's their secret? Turns out, the engines that power rockets are different from the kind of engines that power aircraft or other Earth-based equipment. Rocket engines carry everything they require into space, rather than relying on air. Like earthly engines, rocket engines operate using combustion. Since all forms of combustion need oxygen, rockets carry an oxidizer like liquid oxygen up to space with them. That means they don't have to rely on surrounding air as a car engine does. Earth's atmosphere acts as a continual drag on spacecraft and the International Space Station, forcing them to fire rocket engines periodically to prevent falling back to Earth. So missions in all but the highest Earth orbits must carry enough fuel to prevent that falling back from happening. There are very precise measurements of how much fuel to put in the rocket, depending on the size of the rocket, the type of fuel, and everything that adds to the mass of the rocket. As we conclude this incredible journey through the science of rocket propulsion and space travel, we hope you have gained a newfound appreciation for the power and precision required to launch objects into the great beyond. We have explored the complexities of space propulsion and learned how it has been revolutionized over time to make space exploration a reality. Don't forget to subscribe to our channel or you will miss our